Assalamu alaikum. Can you all hear me? Okay. Yeah, inshallah. Okay, so is my voice good or is there any disturbance in the voice? Okay. Fine. Yeah, and you all can see the screen too. Okay, so is my voice very low to just Mustafa only or everyone's facing the same issue? Is my voice actually very low or like is it just Mustafa? नो सर आवाज सही है मुस्तफा आप चेक कर लें अपना. Okay, so if you all can see the screen, then let's start with the session. Uh, just one more thing before I start. Okay, so the idea behind this whole thing would be that obviously we're just doing some revision session just before the paper, so it won't be possible for us to like do like the actual theory and like go in a lot of detail. So the idea would be that I'd be compiling some past paper questions that I feel might be important or are as such that they summarize kind of like most of the they kind of summarize the type of question that you could expect in your exam. Obviously, it could be the case that the question might be a bit different, but if these questions are a bit clear to you, then chances are you'll be able to like do the exam properly. So that's how we'll be proceeding. But if at some point I do feel the need that I need to go into the theory a bit and explain it in detail, I will do so. Okay, and I would like to keep the classes as interactive as possible. So those of you who would like to respond on chat, do so. And those of you who would like to open their mics and speak, like ask questions or like interact, I would also appreciate and be open for that as well. And that's the whole idea. Okay, so if you start with this question, and I've also arranged these questions in a way that we could obviously like progress uh, 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 basics by basics. Okay, so the question is, yeah, I will do so. Uh, okay, so question two is, figure 2.1 shows a skydiver falling vertically downwards at terminal velocity. And we do know the case of terminal velocity. Terminal velocity is when the air resistance of acting on the object equals its weight. So that's what we know, already know by terminal velocity. So if that's what they told us. If that's the statement, terminal velocity, the first thing that should come to your mind is weight equals air resistance. Okay, so and following this in the next part A, one, state the name of force X and the name of force Y. So can anyone tell me what these forces might be? Like obviously, I just told you that if it's terminal velocity, air resistance equals weight. So obviously, these forces might be either of these. But which one's the downward one and which one's the upward force? Y and X. Can someone just tell
Why
me?
is why is air resistance?
Y is air resistance because it's acting upwards, and X is weight, right? X would be weight and Y would be air resistance. Okay, so I won't be writing all these things again and again. Like it would just take time. So if I've just said these things and it's clear to everyone, we'll just proceed. So force X would be weight and force Y would be air resistance. And the next part is explain why force Y acts upwards. So we do know that Y is for air resistance, and the question is why is it acting upwards? So can someone tell me why is it upwards? Like why can it not be downwards or towards the right, towards the left? Why is it only upwards in this case, at least?
Because air resistance is a form of friction. Friction is always opposite to the other force.
Friction is you're close, but you're not like 100% correct. Friction opposes motion, not force. So it could be the case sometimes that force and weight and friction might be in the same case. For example, if you're throwing a ball upwards, you throw the ball upwards, the ball starts moving upwards, the air resistance acts downward, and so the weight. So it's not necessary that air resistance is always opposite to other forces, but what's always the case is that air resistance is always opposite to motion. So since the motion of this skydiver, which they've told us, he's falling vertically, so he's moving downwards. So if his motion is downwards, air resistance would always oppose this and would be upwards. So that's the actual reason, because it's opposing motion as all resistive forces do. The next part, when the skydiver first started to fall, forces X and Y were unbalanced. And can someone tell me, they've told us that they were unbalanced, but can someone tell me what the unbalance actually was? Which one was greater and which one was smaller in these two?
Force X was great.
Force X was greater. Yeah, you're right. Force X was greater, and we can even say that initially force Y was zero. So obviously it was X was greater than Y because Y was zero. Because when the object just started to fall, it had no velocity, and when there's no velocity or speed, there is no air resistance. Because air resistance always opposes motion. There's no motion, there's no air resistance. Okay, so describe and explain the effect of the unbalanced forces on the motion of the skydiver. What would be this effect of this unbalanced force? Like what like just even forget what they're asking us, an effect of unbalanced forces on the motion of the skydiver. Just forget about the skydiver. What's the effect of unbalanced forces? Whenever there's unbalanced forces, what do? Whenever the forces are unbalanced, what do?
Acceleration in one direction.
Yeah, whenever the forces are unbalanced, they cause acceleration. So in this case, it's they're asking us how does this affect of unbalanced forces? What's the effect on the motion of the skydiver? So the skydiver starts accelerating downwards. So that's the effect on this skydiver specifically. Okay, so that would be the answer. The next part is state what happens to the size of force X, the size of force Y as the skydiver falls and reaches terminal velocity. Uh, what's the case of terminal velocity? I just told you that at terminal velocity, X is supposed to be equal to Y. Weight equals air resistance. But uh, how does X and Y eventually become the same? Initially, they weren't. What was the case? Like, can someone tell me that what increases, what decreases, how do each X and Y vary until they become equal to each other? Anyone?
Force Y eventually increases.
Yeah, and does X increase? Okay, so someone just messaged that X decreases. X is the weight, and weights
X
only
stays
depend.
the same.
Yeah, X is weight, and X is only dependent on mass. So unless the dude who's falling loses his mass, like some way, his weight won't decrease, X won't decrease. Y would increase because I told you when this skydiver started to fall, his initial velocity was zero, and so there was no air resistance. So Y was zero, and
So
then
why
Y
the
started
weight
to increase.
decreases?
Why? Why does what?
Why the weight decreases?
No, I'm not saying weight decreases. I'm saying weight does not decrease.
Oh, okay, thank you.
Someone just messaged that X decreases and Y increases. So I was telling him that X cannot decrease because it's the weight. Weight's only dependent on mass. So X cannot decrease. And initially the forces was unbalanced. So obviously Y was lesser. And as the speed increased because of this acceleration, Y increased, and eventually they became equal to each other. And that point was terminal velocity when my acceleration was zero. So basically, this and the next two questions that would this question, they kind of summarize whatever they could ask you regarding this air resistance topic. Like when it comes to forces, there would either be a car or like a box which they would be pushing on two ends, or it could either be a skydiver who's falling. It could either be a circular motion or something like that, or some other questions which we will go through as well. Okay, so now the next question. Uh, a skydiver jumps from a stationary balloon. His initial downwards acceleration is 10 meter per second square. Figure 1.1 shows the direction of air resistance and the weight of the skydiver. The mass of the skydiver is 60 kilograms and his weight is 600 Newton. Yes, Mustafa, I will do so. Don't worry. So explain using ideas about forces why his initial downward acceleration is 10 meter per second. 10 meter per second. Uh, why is that his initial acceleration? Like what are they trying to ask us? There are two forces on the object on this guy who's on this guy. One is air resistance and the other one is weight. If there were no other forces, the downward acceleration, his downward acceleration would have been 10 meter per second. When a person is falling, we expect there to be air resistance, and and therefore we expect that his downward acceleration would be lesser than 10. But it's not less; it's equal to 10. So that's what they're asking us. That using ideas about forces, why is his initial acceleration equal to 10 meter per second? Why isn't this it any less than that? Can someone tell me this about this? Like they've told us that his downward acceleration is 10 meter per second. Why isn't this? Why isn't it any lesser? Because there's this aeration which is opposing this acceleration. Why is it? Why isn't aeration being successful in doing so?
The pull of gravity is equals to 10 meter per.
Yeah, it is. But there's also an upward force which is aeration. So it could be decreasing the force, right? If an gravity is trying to pull the object downwards at 10 meter per second square, but there's this
But
another
initially the
force.
air resistance is zero.
Yeah, that's the answer. Initially, air resistance is zero. Why is it equal to zero? Because initially he just started to fall and he does not have any velocity. His velocity is zero. So when the speed is zero or velocity is zero, there is no air resistance. So and there is no air resistance, so his initial acceleration is 10 meter per second. And then we know by the previous question that as he starts to fall, his speed increases because of a downward acceleration, and as his speed increases, his air resistance acting on him increases, which again decreases the acceleration till a point where the weight equals y and acceleration becomes zero. So from 10 it goes to zero. So the next part, and in this part he also has a parachute which he opens. So they're asking us, when the parachute opens, the skydiver experiences an upward acceleration for a short time. Explain why. Why does the skydiver experiences an upward acceleration even if it's for a short period of time? Why is it that the case? Like basically the idea is this air resistance was a result of weight, and it was a result. Since it was a result of weight, it's supposed to always be lesser than it. That's like where they're coming from. Obviously that's not the case, because that's what they're asking us, but that's where they're coming from. Okay, why isn't why how is it possible for the air resistance to become greater than the weight? Anyone? Okay, so can anyone tell me what are the factors that air resistance is dependent upon? Yeah, Ali. Yeah, there are two factors air resistance is dependent upon. One is the speed, the magnitude of velocity, and the other one is the cross-sectional area. Weight actually causes acceleration, and acceleration causes like results in speed. So speeds what actually causes it. So area, speed, and obviously then there's another factor which is like quite out of a control, which is the density of the medium. So these are the three factors. So the object right now is falling at a certain speed. So the air resistance right now is proportional to that speed for that given area. When the parachutist opens his parachute, all of a sudden his cross-sectional area, or the area, the surface, not the cross-sectional area, let's say the surface area uh, of the of person, or the object that would be resisting air resistance increases. Since the surface area is increased, the air resistance also increases. So air resistance was never dependent on weight. It was like that's the thing which kind of confuses us. It wasn't dependent on weight. It was always dependent on velocity. And right now my velocity was such that my for that area, after I've opened the parachute, the area has increased. And for now, for example, the area has now become 15 meter per second at a velocity of 15 meters. Meter square was the area for a velocity of, like, let's say 30 meter per second. So at these functions, my air resistance could be, let's say, 50 newtons, and the weight is something lesser than that. So the idea is that weight is totally unrelated to this. What air resistance is dependent upon is my surface area and my speed. So for this given speed and surface area, when the parachute opens, it's possible for the air resistance to become greater than uh, the weight, and therefore, since it's greater, so uh, the resultant force acts upwards and he accelerates upwards. So we could it's a 1 mark question, but like I went to in quite a lot of detail to explain this part. He experiences an upward force because the increased surface area increases air resistance, which like makes a resultant force in the upward direction. So that would be the answer. The next part, the total force of air resistance on the skydiver and open parachute changes with their speed as shown in figure 1.1. After the parachute opens, the skydiver slows down to a terminal velocity. The weight of the skydiver is 600 Newton. Part 1, using figure 1.2, determine the terminal velocity of the skydiver. Can anyone tell me how do I do this? The method. Okay, so what we know is at terminal velocity, the air resistance must be equal to weight. So I'm just writing air, I'm not writing the whole time. Air resistance must be equal to weight at terminal velocity. So if the weight is 600 Newton, at terminal velocity, my air resistance is also supposed to be equal to 600 Newton. So if it's equal to 600 Newton, I locate this point on the graph and I see what it corresponds to. As per this graph, it corresponds to a speed of 5 meter per second. So that would be the terminal velocity. Yes, Ali is right. The next part, calculate the resultant force on the skydiver when his speed is 5.5 meter per second. So for this, we obviously locate this point 5.5 meter per second, and we now trace this graph vertically upwards. We reach this point. This becomes something around 700 or 710 Newton. So that would be the air resistance acting on the object at this point. Let's say 710. It's probably 700, but let's just say it's 710. So 710 becomes my downward force. So I had two forces here right now, the upward force. So air resistance becomes equal to 710 Newton, and the weight becomes equal to a weight which they've already told us is equal to 600 Newton. So just by looking at these, I know that my resultant force would be in the upper direction and would have a magnitude of 110 Newton. So this would be my resultant force that I would write here in this part. Okay, so is this part clear to everyone? If anyone has any question, feel free to ask. Okay, so let's move on to the next part. And this is basically, previously it was just air resistance and those things. Now there are like some other forces which like have been added to this part as well. So, okay, so it's probably 100, I think, but I don't know. Was this part clear to you where I found air resistance to be equal to 710? Like I could be making a mistake because I'm just doing it on my tablet. So I'm not going for exact values, but this point somewhere here. So if my resistance was 710 Newton, which is upwards, and weight was 600 Newtons, which was downwards. So obviously I just apply the formula 710 minus 600, I get 110, which would be upwards. So that's my resultant force. Okay, so the next part, uh, draw a line from each box on the left to the correct description of each force. So obviously there are four type of forces, and these four type of forces, these are the minimum type of forces, that these are the like the least number of forces that would act on a car that's moving. So can someone tell, or if you just like yeah, can someone tell me what would force B be equal to? Like what's force B? Yeah, driving force. But what is force B? Like force B is a force that is accelerating the car forward. So obviously from that we know that it must be the force that the engine is providing. Therefore, it's the driving force. So force B would be my driving force. The next thing, the next force which I would like to ask about is force C. Force C is a force that is acting on the car and is downwards. So what's this type of force most of the time? Gravity. Yes. So force C would be force of gravity. And what would force A be equal to? Yeah, and why do we have force A? Like what's the reason? Why is there force A? Why is there a contact or normal force or a reaction force? Uh, Not necessarily Newton's law, but Newton's law states that the type of forces is the same. So you're probably you probably might be telling me this to be the reaction force of gravity. So the reaction force of gravity is not contact force. The contact force is a result of the contact force, which is right here. So those forces are different. So nonetheless, the idea is that gravity is pulling this car downwards, and it's causing an acceleration, like it's supposed to pull the car downwards, but there's this opposing force which is opposing this and not letting gravity pull the car downwards. This is the contact force. Yeah, Ali, you're right. When object A exerts a force on object B, then object B exerts a force on object A, but that also requires that the forces be of the same type. So that's like a prerequisite. So gravity is not equal to a mechanical reaction force. So both are different types. So obviously, if you want to talk about reaction forces, the reaction force of gravity would have been like there are two types of gravities. Like when this car is attracting the earth is also attracting this car. So both of these are action reaction forces. And as for the contact force, though it is equal in magnitude and opposite in direction, but it's not of the same type. Okay, so force A would be the contact force. And then I have force D. And force D, obviously, that is air resistance and friction. And obviously, we also know that if the object was being accelerated forwards by force B, so it would move in that direction. And since it has a motion on towards the right, there would be a force that would oppose this motion. Always there would be a force that would oppose this motion, and that would be known as air resistance. Okay, and what would be the relation between force A and C? Uh, would they be equal? Would A be greater than C? Would C be greater than A, or what? Equal, yeah, they would always be equal because like Ali was arguing that that's Newton's third law. Okay, and force B and D, they won't be equal. Like B would either be greater than it, or like sometimes B would be greater, sometimes uh, B and D would be equal, and sometimes D would be greater than B. Like that's also possible. Okay, so that's what they've done in the next part is they've given us the mass of the car. Calculate the mass of the car. So obviously, we know force C, which they've told us that it's equal to 8,000 Newton. We have this formula that weight equals mg, and we know 8,000 equals 10 times m. So obviously we find mass by this, which comes out to be equal to 800 kilograms. The resultant force on the car, obviously A and B equals out, so there is no resultant force in the y direction. The only resultant force would be in the x direction. So for that, we subtract force D from force B, and they turn out to be 1000 minus 600, and I get 400 Newton. So that's my resultant force. And the next part is the acceleration of the car. So acceleration of the car is obviously, we know the formula for it, force equals mass times acceleration. Now we know that the resultant force in the right direction is 400 newtons. So if that's the force, that's the resultant force 400, and I know the mass, which is equal to 800 kilograms. So I just put in this formula and I end up with acceleration being equal to 0.5 meter per second square. And the next part is at another time the car is traveling at speed u. It then accelerates for 5 seconds with an acceleration equal to 1.6 meter per second square and reaches a speed of 20 meter per second. Obviously, this part is a bit related to kinematics, and we know the formula for acceleration, which is equal to v2 minus v1 over time. And I know v2 is the final speed. Okay, so to explain the resultant force again, so they've told me the magnitudes for all these forces. Just a second. They told me the magnitude for all these forces. Force P is equal to 1000 Newton. Force D is equal to 600 Newton. force A is equal to 8,000 Newton, and force C is also equal to 8,000 Newton. So force A and C are equal to each other, so they just cancel out, and I have no resultant force in the vertical direction. My only force, resultant force, would be in the x direction. For the x direction, I have a force to the right, which is 1,000, and I have a force to the left, which is 600. So 1,000 minus 600, uh, yeah, 1,000 minus 600, I get 400. 400 Newton would be my resultant force to the right. I hope that explains. Okay, so then I know the mass, I know the resultant, I know the mass, I know the resultant force. I can find the resultant acceleration. So that's how I do it. Coming to the next part, I know this formula. If it's not clear, then do let me know. Okay, so the next part, v2 minus v1 over t. v2 is the final speed, v1 is the initial speed, t is the time taken for this acceleration, and a is the magnitude of acceleration. So I know that a is equal to 1.6, which is equal to the final speed, which is 20, minus the initial speed, which is u, divided by time, which is 5. So I rearrange this whole thing, and I think I'll end up with 12 meter per second. So that will be my answer if you just solve this. So coming to the next question, and both these two questions, if this was clear to you, like how we found the resultant force and what are the forces that act on a car, this next part would also be very clear to you all. So the question is, state what is meant by friction. So obviously friction is a resistive force that opposes motion. So that is what friction is. A force, it's a resistive force. And what's this, the quality or the uh, an attribute of this force? It's that it opposes motion. Now if you read the question, the car is traveling along a straight level road. Part 1, the forward force A and the backward force B are equal. Describe the motion of the car. So obviously if force A and force B are equal to each other, there would be no resultant force, because it's always A minus B. So when we do that, we get a resultant force which is equal to 0, and the resultant force is 0, so there is no acceleration. It's moving at constant velocity. Yes. The next part, the mass of car is 800 kilograms, force increases to 5,000. This causes the car to accelerate initially at 1.5 meter per second square. Calculate the size of force P. So what I know is, and these type of questions are very important, because this time I cannot, although the formula is still force equals ma, that's the important part. The formula is still equal to F equals ma, but I cannot equate this. I cannot say force 5,000 equals 800 times 1.5 meter per second square. Why is that the case? Because when I talk about this formula, F and A, both are supposed to be resultant. So in this formula, the only things there are resultant. So resultant force equals mass times resultant acceleration. As per the diagram, we know that force A is not the resultant force. The sum, like when I subtract force B, when I subtract the magnitude of force B from the magnitude of force A, then I get my resultant force, and then it's equal to mass times the resultant acceleration. So they've told us the acceleration. So whenever they, by the way, whenever they give you some acceleration in your question, that's always equal to the resultant acceleration. Like there is no concept of relative like in forces, unlike forces, acceleration would always be the actual acceleration. So I cannot apply this, and this is the important part. So instead, what do? I apply things differently. So I say F resultant equals mass times acceleration. So my mass is 800 and my acceleration is 1.5. So I get this to be equal to 12,000 Newton. 12,000 Newton is my resultant force. And this, I know, like if I have an object here and there's a force acting on this direction, which is A, and equal to 5,000 Newton. And then there's another force which is on the left, which is B, and it's equal to, like, I don't know, it's P. it's just p. And then I would like subtract both of these, and I would know, like for example, if I knew that b was equal to, just for an example, like b was equal to 2000, I could have subtracted both 5000 minus 2000, and I would have said that my resultant force is to the right, F resultant, and it's equal to 3000 Newton. So this is how I would have done this. But right now it's the reverse. I need to do this in reverse. So I know that my force, my resultant force, is equal to 5000. Sorry, not 5000, 12,000, 1200. So I know this is equal to 1200. And obviously, if I do the mathematics, I'll end up with the force B, which would be equal to 3800 Newton. So I just do this in reverse, and then I get my answer. A car of mass 800 kilograms climbs a hill and rises a vertical distance of 20 meter. Calculate the gain and potential energy of the car. Okay, so since we're not doing questions of potential energy, so I'll be skipping this. But if someone wants to, I'll just explain like verbally how it's supposed to be done. We know the mass, we know the vertical distance, and that's the vertical distance it rises. We know the formula. Potential difference equals mgh. Mass, which is 800, times gravity, which is 10, and times the height or the change in distance, vertical distance, which is 200. So we multiply all of them, and we get something around, I think, 16,000 joules. Now the next part, the next question is also similar to these. So maybe like uh, mark this thing. It's May June variant 2 to the 2014 variant 2. So maybe like try doing this yourself, because it's obviously almost the exact same thing. State and explain whether D or B is the larger force, and they've told us that forward direction force is D and the backward force is B. So we know backward force is resistive force. We know the forward force is the driving force, which is D. So obviously, uh, if the lorry is accelerating, so obviously the forward force is supposed to be greater than the backward force. So D is larger than B. So obviously, try solving this, mark this question. Now, this question and the next one are a bit similar. So I'll be doing this, and I would suggest that you all mark this question. It's October, November 2010, variant 2. So maybe like try solving this. I'll solve this one, and they both are, or maybe I'll just do this. Like it's a short question. Okay, so state the difference between speed and velocity. So we know the difference. Speed is vector. Speed is a scalar quantity which does not have a direction, whereas velocity is a vector quantity which does have a direction and a magnitude. Calculate the change in velocity of the cricket ball. So we need to find the change in velocity. Velocity, we just told them above, it has a direction and a magnitude. So obviously the sign of velocity matters. So they've told us the cricket ball has a mass of 0.16 kilograms, and it hits the ball bat with a speed 25 meter per second. So like if this is my bat, this ball comes and it hits the bat at a speed of 25 meter per second. After being in contact with the bat for 0.0013 seconds, the ball rebounds with the speed. So they're just telling me the magnitude. They're not telling me the velocity. They're just telling me the speed. The magnitude of velocity which it rebounds with is 22 meter per second. So since it's rebounding, it's obviously in the opposite direction like this. So 22 meter per second, it rebounds back in this direction. They're asking me the change in velocity. So if the question was change in speed, I would have just minus 22 from 25, and I would have written 3. But right now we're talking about velocity. So if I talk about velocity, there's 22 meter per second. Since it's in the opposite direction, and I took the direction towards my right to be positive, it would be equal to negative 22 meter per second. And change in velocity, we know that change in v, delta v or delta, whenever it's there, it's v2 minus v1. So it's the final minus the initial. So my final velocity is negative 22 meter per second minus my initial velocity, which is 25 meter per second. So I get 47 meter per second, negative 47 meter per second. A negative 47 meter per second. That would be my change in velocity. So that would be the answer. The next part is they're asking me about the average acceleration of the ball. So I know the formula for acceleration. It's equal to change in velocity over change in time. So I just found my change in velocity to be equal to -47, and the change in time they've given me, and it's equal to 0.0013. 0.0013. So I just do this, and I'll get my average acceleration, which I think would come out. Can someone tell me? Yeah, do give the answer in negative. And yeah, do give the answer in negative. But even if you don't, in this specific question, it won't matter much, because the negative sign basically means that you first define a direction which would be positive. Like you'd first have to say towards my right is positive and towards my left is negative. So that's relative. Another person could say an object moving to my left is positive and to my right is negative. So uh, it does not matter much in this case. So the answer I'm being told is coming out to be 36 kilonewton. And by the way, when it comes to O-level physics, uh, three significant figures is more than enough for your answer. And sometimes even if you write the answer in two significant figures, that's even sufficient. So 36 kilonewton. 36, sorry, not kilonewton. So not 36,000 kilonewton because it's the acceleration. Let's say 36,000 meter per second. And now the force, I need to find the force. This is my uh, average acceleration. I know the mass of the ball, which they've told me to be 0.16 kilograms. I multiply both with each other and I'll get my force. So F equals ma. So that's how we'll do this. The next question. Yeah, like since it's quite similar, so I would suggest that you all do this on yourselves. So you can write this question down. October, November 2015, variant 1. So it's just the same as the previous one. So like, try doing it on your own. Okay, so now we move on to the next part, which is circular motion. So, and obviously these are mostly the type of questions that you could expect in your exam. So right now, the space station is traveling at a constant speed in a circular orbit around the Earth, as shown in figure 9.3. Force acts on the space station to keep it in its orbit. Draw an arrow to show the direction of this force. A force acts on the space station to keep it in its orbit. So it's like something which is keeping it in its orbit. So like something, in other words, something which is making it move in a circular path. So what like if it's allowing it, making it move in a circular path, what's this type of force known as? Yeah, but what's the name of this force? Centripetal force. Centripetal force is the one which causes the circular motion, and as per the third law, the reaction force to centripetal force is centrifugal. So that centrifugal is a bit different. Okay, so and that's the centripetal force. So it's supposed to be towards the earth, like towards the center of my of where the circular motion is, like uh, uh, what the orbit is. Explain what causes this force. Now we just need to explain the cause of this centripetal force. So the cause of the centripetal force is the gravitational force of attraction by the Earth on the satellite. So that would be the answer. What is meant by velocity of an object? You all know this, like this change in displacement over change in time. And the next part said and explain what happened during the orbit to the velocity of the space station and the kinetic energy of the space station. And this part is very important. Like what happens to the velocity of the space station? Can someone tell me what happens to the velocity of space station? Does it remain the same or it changes? Velocity changes. And what about the speed? It remains the same. So velocity changes and speed remains the same. So for the first part, I write uh, it remains the same. Sorry, it changes. And the kinetic energy of the space station. Now the formula for kinetic energy is 1 over 2 mv squared. So 1 over 2 mv squared. V square means that kinetic energy is only dependent on speed, like the magnitude of velocity. It's like centrifugal force was caused by the gravitational force of attraction by the Earth on the satellite. So that was the cause of centrifugal force. Not centrifugal, like centripetal. And centrifugal was caused by the gravitational force of attraction by the satellite on the Earth. So you just reverse the thing. Centripetal force is the one which is where the force that I circled right now. So here is centripetal, not centrifugal. And the reaction force to this centripetal force is centrifugal force. So I hope that clears some. Okay, so I was talking about kinetic energy. Kinetic energy is 1 over 2 mv square. So it like depends only on the magnitude of speed, velocity, which is speed. So the velocity was only changing because its direction was changing. In circular motion, the magnitude of velocity does not change. Its direction is only what changes. And since in kinetic energy we have 1 over 2 mv square, so the sign does not matter. So it's only dependent on the magnitude of velocity. So since the magnitude or the speed is not changing, my kinetic energy also does not change. Okay, so uh, I did want to do like this question and one question from circular motion as well, but we're a bit out of time. So we'll do this we'll do this tomorrow inshallah and then continue with the next part. So, and by the way, like just to update you guys with 2 3 things, we were supposed to do the topic of force and moment or the turning effect today, but we just did forces. So I will be doing a turning effect tomorrow, and then we'll be like short on a class as per what I made my schedule to be. So I'll probably be doing a class on maybe like Saturday or somewhere like that, an extra class somewhere in the evening to like cover this up. And from tomorrow we'll probably be doing extended classes because like today the class was short, and obviously like I have some there's this Isha namaz which I needed to attend at 9 p.m. because of which I was late. So from tomorrow I'll probably be starting the class at 8:30. I'll update you all on the group in the group. So we'll probably start at 8:30 and we'll do a 10 minutes break around 9 p.m. for Isha, and then we'll continue the class till 10. Okay, and like if there was any confusion what we did today, or there's any confusion when you guys are like practicing on your own, so like feel free to ask in the group, or like you all have my personal number as well, which is like the admin of the group. That's me. So you can ask questions directly as well. So have a nice day and good luck for your P4 ATB tomorrow. So good luck everyone. Assalamu alaikum.